Hello, it's time to play some dominoes. Let's solve pips. We'll start with the easy puzzle as usual. All right, we have a 12, so two sixes go into that. And then one of them crosses over into a four-sized equivalence region, and that will need to be fives, it looks like. So that goes there, two fives go here. Our last five goes here, that's straightforward. The other six goes here. Oops, we need a five to... oh, wait, what have I done? Oh, sorry. Wait. Oh, have I done something wrong? I must have done. We must not have enough fives to do that. Okay, sorry, I made a mistake. Assuming it was fives that go in the equivalence. What is it actually? Is it ones? No. Oh, we have three sixes. Sorry. One of them is a two. Do we? No, we don't have enough twos for that. Sorry. I can't believe it's the easy puzzle. I'm already making a total mess of this. The 12 can only be two sixes. What am I missing here? Our choices are 2, 5, and 1. Oh, no, sorry. I was right the first time. I was wrong with putting the... yes, sorry. I used the wrong 6 here. That needs to be a 1, and then it's the 6 that finishes it. Right. I only saw the two sixes when it was time to fill out the 7. There we go. Sorry. Okay, so now we need a 4. We also need those 5s again, that part was correct. And that goes there. Okay, so now we need a 4. And I guess either... oh, no, yeah, it needs to be this one because we need the less than 3. We need the 0 from the less than 3 to fill that in. Okay, sorry, I don't know why that took me that long. Just overlooked one of the 6 dominoes for some reason. All right, move on to medium. Hopefully this doesn't trip me up quite as much. Okay, so we need 4 of something. Let's not make the same mistake. So that could be 4 1s. I think it has to be that. Is that right? Sorry, let's just make sure I don't make the same mistake. We only have 3 6s, 3 5s, 3 2s. Yeah, okay. I think it does need to be 1s. So the double goes there. Then what about this 21? Looks like we need 3 6s and a 3 because the bigger option extending from a 1 is a 3, and that would allow us precisely to finish the 21 with 3 6s. So that does have to be the case. And we only have 3 6s, so those go in there, which means we need 5s in the equivalence region. So one of them will point up into nothing. The other one, I'm not sure yet exactly, but our other 1 goes here. That we know. So now, okay, so the other 5 from the equivalence region will point up into the 6, I think, because we can't have a double. We can't put an entire domino in the remainder of the 6 because it'll be too high. So we need 3 2s. So one of those 2s is a 5 that points down. The other one is a 3 that points over here. And then finally, the equivalence region is finished with the 5. And there we go. Okay, that wasn't too bad. Let's try the hard and see how this one treats me today. Oh, interesting. We've got a 5-sized 5 region. So only 1s, 2s, and 0s in there. And we will need some 0s because we only have 2 1s. So we can't make the whole thing with 1s. Actually, could it be possible to have a 3 in there? It is possible to have a 3 in there. We could have a 3, 2 1s, and 2 0s, conceivably. That's actually possible with what we have. So yeah, not sure about that one yet. We also need 3 of something, 3 of another thing, and 3 of one more thing. So we need 3 sets of 3, which could be 4s, 5s, 0s. Wow, it would be really interesting if it were 0s, because that would heavily constrain the 5. I don't think that's definitely not possible, because we don't have enough 1s to do that. So the 0s can't be an equivalence region. Yeah, we're really constrained on small digits, actually, between that 5-sized 5 region and the 2-sized 2 region. across all of those, there's an average of 1 pip per space, if you see what I mean. There's exactly 7 spaces between those two and a count of 7 between them. So that is interesting. So what does that mean? I'm not sure. There's probably a way to kind of use arithmetic to add these up and figure out exactly what dominoes we need for that, but I'm not going to until I determine I need to. So anyway, what are our 3 sized possibilities? We have at least 3 4s, at least 3 5s, and 3 6s. Okay, I think that's what it'll be. It'll be 4s, 5s, and 6s. That makes sense because we need to use up all of these high numbers because we need low numbers elsewhere. So 4s, 5s, and 6s. Okay, and one of them is going to need to point into a less than 4. So it could be this 4, 3, could be this 5, 3, could be a 6, 1, a 5, 1. Okay, so that's not hugely constrained. And actually another one points into a less than 4. That's interesting, I guess. One of them is doubled. We have a doubled 5 and a doubled 4. One of those two will need to go here because just geometrically it will. Oh, and the other one needs to go here. These might have to be opposite for some reason, but I'll put them there just to remind myself that we do need those two in those two spaces, either in this disposition or the opposite. It'll be one of the two. So what about this 4? Does that 4 could point this way? But we could do exactly the same thing with that 5, 3 there. So yeah, I don't know. I'll leave this here for now. This 5 will also need something, a sort of full domino within it. Actually, it'll need 2 full dominoes within it, if you see what I mean, because, one of them could go here or here, but if it goes here, we'll need another full domino here, and if it goes here, we'll still need another full domino here. So this 5 includes 2 complete dominoes, and exactly 2, because then there won't be enough room for a third one. So it'll have 2 complete dominoes and then another half. I assume one of them needs to be the double 0. I mean, I think that's likely. I don't necessarily know which way it goes. The other lowest thing we could put in there would be a 0, 2. That would leave us exactly 3. In fact, it might need to be these 2s now that I'm thinking about it, because everything, looking at all the other remaining dominoes, they're all much too high. So it is actually exactly these. So it's these 2 and then a 3. And actually, we only have 1 3 left. And it'll be either the 3 5 or the 3 4. It still could be this one. It could be this, because we could swap the 5 and 4 around. This could be there. Then we'd have the 5 3 here. I still don't know which way that goes. And then the 4 4 would be here. I don't know if that's what it'll be. Oh, actually, yeah, it's interesting. Whichever one it is, we'll need to connect to the 5. Right. Interesting. Because those are our only 3s. So, okay. So how does that work then? Does it go... Let's see, I'm just going to move these around a bit. Does it go here and then the 4s are there? That doesn't make any sense. That's not possible. Okay, I might have missed a configuration. Maybe there's another way to do this. I think there is another way to do this, possibly. Could we connect a 5 with a 1 and point that up? No, that doesn't make any sense. We can't do either of those things. What about this? Maybe this is the way to do this one. Because we have lots of 5s. Do we have 6 5s? No, we don't. I was wondering if we could make 2 of our 3 regions be 5s. I don't know. I think I missed something geometrical about how to make this work. No, but I think we do need two entirely contained dominoes in the larger 5 region, because we don't, maybe we, yeah, we can't have anything pointing down, or it ruins the geometry. It's just not possible. Interesting. So one of, yeah, how does this work? Sorry, I'm probably missing an obvious possibility for how this works. I apologize for this. Let me just see. I'll just mess with this. Yeah, there must be another way to do this, because this just doesn't make sense. Sorry about this. Maybe the 5, oh no, it's probably, it's just that the -4 isn't a 3. Sorry, that's it. I keep missing these really obvious things recently. Sorry, it's that the less than, not -4, it's that the less than 4 isn't a 3, it's just something else. I feel like I'm so accustomed to the less thans always being off by 1, but they're not, there's no reason that needs to be the case, obviously. So then this 3 could just go here, for instance. I mean, I'm not saying it does, I just mean in theory it could, but it doesn't, because then we don't have a double for our equals. So how does this work then, actually? I'm back to being confused. Huh. I feel like we need a 6 pointing down to that. No, that wouldn't, oh no, that would work in theory, but it doesn't work with the 5. I'm missing something clearly here, and I don't know what it is. What is it? What am I missing in terms of how to do this? The 2, oh yeah, this also ruins the 2, doesn't it? Yeah, this doesn't work. This would need to be 5, 3. But then how do we ever finish the 5? Sorry, I'm really missing something important about how we can orient these dominoes. I'm missing something important here. Don't quite know what it is. Oh, maybe the 3 goes up here. Does that help? Or A3 goes up here. No, then we kind of ruin our 2. Yeah, we do need both of those 1s, don't we? I feel like I'm missing something about how the 5 can be oriented. I just, having one of these days, aren't I? I just do this sometimes with pips where I just can't, there's just something I'm missing that I can't see for just ridiculous reasons. Oh, this is almost right. Maybe, oh, maybe this would be right if I swapped the 5s and 4s. It is. Why could I not see this? Why was I not able to see this? I don't know. Sorry, what was I missing here? I was right about the large 5 region and how that needed to be oriented. I mean, I was right that it was one of 2 orientations, one of 2 dispositions of those. I was right that the 5s and 4s needed to be in one of those 2 sort of diametrically opposed equivalence regions. I was even right that this less than 4 over here was going to be a 3. So what was I not seeing that disallowed me from completing this? I don't know. I'm sure I was making some repeated boneheaded oversight. I apologize for that. Got there in the end. Those were the pips. Back tomorrow. Bye for now.